Okay, class, to start a new unit on thermochemistry and thermodynamics, I'm going to start with a demo. All right, I have a heavy piece of wood here. I'm going to put some water on it. All right, enough water. I have a beaker, and I'm going to mix two chemicals. I have here ammonium nitrate. It is a solid. Ammonium nitrate, as you can see, solid. I'm going to pour it here in my beaker. And I have another chemical. Why don't I write ammonium nitrate so we can see exactly the reaction. All right, let's calibrate. Ammonium, the formula for ammonium is NH4, it is 1 plus, therefore nitrate is 1 minus. So this is your ammonium nitrate. And we are going to react it with barium hydroxide, octahydrate. All right? Barium hydroxide, octahydrate, two solids. So I have barium, group 2, 2 plus, hydroxide, OH minus. You need 2 hydroxide for it with barium, and it say octahydrate. So you put in that 8 water, and even though you see the water here, the water of part of the crystal is still a solid. All right, we have 2 solids, and we will mix them together. So I'm going to ask, I start smelling something. So I'm going to ask a volunteer to come quickly here. You are going to do 2 things for me. You are going to touch the beaker to see what happened to the temperature. And I also need for you not get your nose too close and swap it to see exactly if you smell something. Don't put your nose too close. You can come right here, right now. Touch the beaker. How does it feel?
It's cold.
Very cold. Okay, how about if you try not to get too close? Okay, swap it in your nose. Bring it with your hand to your nose and tell me if what do you smell?
It smells like almost powdery. Like,
Is it a strong smell?
yes.
How about the state? What do you see the state? What is the state? Liquid. Okay? So now it's turning completely into a solution. So you feel it? Okay, thank you. I'm going to measure the temperature of that liquid. We start with 2 solids. 2 solids. All right? And this is what happened. Now, can we see exactly, do you see what is under the beaker? It is ice. It is ice. So when you touch it, it is extremely cold. It freezes the water on the wood. So I have my LabQuest ready here with my temperature probe. I'm going to take the temperature. Now it says this is room temperature. It is 25 degrees Celsius. Okay, I'm putting it in the solution right now, and we are going to read the temperature, give it a few seconds, so it completely down, going lower than 0. So I'm going to ask you, we are going now to write a balance equation. So if you want, you can come later and say, we have few ice in here. So we are going to talk exactly negative. The temperature is lower, below 0. Let's write down an equation with what is going on here. So we have ammonium nitrate plus barium hydroxide octahydrate. We have, if we do a double displacement reaction, we have ammonium hydroxide. We have NH4, hydroxide, OH. But what happened is the ammonium hydroxide will decompose into ammonia. This is NH3 and water. Okay, that very strong smell is the smell of ammonia gas. Ammonia gas. It is a solution now. We have water molecules, and we also have barium nitrate. Did I do a double? This is barium nitrate and ammonium hydroxide. We have a soluble salt. So what you are going to do with me now, help me do, is put energy on one side of the equation. Why don't we define a system? A system is exactly the chemical reaction going on inside that beaker. This is my system. My system is whatever you are studying. Everything outside that system is called the surrounding. My system is ammonium nitrate reacting with barium hydroxide. So now, we put the temperature in here, it is below 0. I need for you to tell me if the reaction is absorbing heat or releasing heat. Remember, it is the temperature went down. Is the reaction absorbing heat or releasing heat? You can talk to me. You can talk back. Is it releasing heat or absorbing heat?
Absorbing.
It is absorbing heat. The system, the reaction is taking heat in from the surrounding. That's why the reaction, that's why it feels cold, because it's taking heat in. So if I were to add energy on one side of the equation, should I add it on the reactant side or on the product side? It is on the reactant side. So my heat, I need to write my heat right here on the reactant side. It is taking heat. Students usually get confused between the system in this case. For them, because I'm putting the temperature in, I'm measuring the temperature went down, they think that it is releasing heat. But it's taking the heat in. That's why I feel it cold. All right? So this reaction, because it's taking heat in, is that reaction endothermic or exothermic? It is endo. It's taking heat in. So this is to start our unit. So I need for you to go over, make sure you write the prerequisite part 1, and then you come ready to do your 19A quiz. All right? So enjoy the rest of your day. Bye.